Hello friends, in this session I will discuss the previous year questions which have been asked in Civil Services Prelims examination. These questions belong to physical geography and the first portion which I will cover here is climatology. Why are dewdrops not formed on a cloudy night? Friends, always remember that dew means the minute water droplets which are deposited over cold surfaces like grass leaves or rocks during winter season. Dew formation takes place due to condensation of water vapor over cold surfaces like grass leaves or rocks. Correct? So, when ground is cold, the water vapor condenses and that leads to formation of dewdrops. So, for formation of dew, the ground should be cold. The surface is very cold. And for this thing to happen, surface will be only cold when there is excessive loss of heat by the earth to space through terrestrial radiation. Rapid loss of heat by Earth's surface to space, that favors cooling of the ground. Correct? Any barrier in the path of terrestrial radiation, maybe clouds or water vapor, they keep the Earth's surface warm even in winter. That is called as greenhouse effect. So, clouds and water vapor particles, they keep the ground warm even in winter season through greenhouse effect. And by keeping the ground warm, they prevent the formation of dew. So, dew will not form if there is high humidity or there are clouds in the sky. Correct? So, why the dewdrops do not form on cloudy night? First, clouds absorb the radiation released from the Earth's surface. Always remember, this is Earth's surface, this is incoming solar radiation. Earth will radiate the heat back in the form of long waves during night, that favors cooling of the ground. But if there are clouds, you know what? Clouds radiate the heat back to the ground. So, they do not absorb. If they absorb, do not cause radiation of heat back to the ground, ground will be cold. But clouds do not that. What they do? They reflect the radiation back. So, they radiate the heat back to the earth surface. So, B statement, clouds reflect back the earth's radiation. This is correct statement. Clouds actually do what? They do not allow the terrestrial radiation to pass through them. They reflect back a portion of terrestrial radiation and prevent excessive cooling of ground and dew formation. So, in this question, the second statement is correct. Third statement is also incorrect. Why? Because our surface would have low temperature on cloudy nights. I told you, on cloudy nights in winter season, the clouds exert greenhouse effect. Always remember, summertime clouds cause cooling through albedo effect. Winter time, same cloud will have warming through greenhouse effect. D is also incorrect. Clouds deflect the blowing winds to the ground level. No, this is incorrect. So, B is correct answer. Clouds reflect back Earth's radiation, and that's why they prevent excessive cooling of ground during long winter nights. The next question is, this question is about a particular climatic and biotic region. What is the question? Each day is more or less the same. The morning is clear, bright with a sea breeze. As the sun climbs high in the sky, heat mounts up, dark clouds form, and then rain comes with thunder and lightning. But the rain is soon over. Which of the following regions is described in the above passage? The question is talking about a region where all the days of the year are same. Every day, the nights and mornings will be relatively cool. As sun goes high in the sky, due to high insolation, ground is heated up. There is evaporation, ascent of air, formation of ascending currents, which leads to formation of clouds and rainfall. But rain duration is very short, correct? And intensity of rain is high, means rain is heavy with lightning and thunder. Definitely this region is equatorial type of region. This statement is about equatorial type of climate. In equatorial climate, you know what happens? The sun rays fall vertically throughout the year. That's why every day, entire year is same. Seasonality is absent. Every day there are warm and humid conditions, and nights are relatively cool and dry. As sun goes overhead during the noon time, there is heating, there is formation of ascending convection currents, and these ascending convection currents develop thunderstorms. The thunderstorms cause convective rain with lightning and thunder, correct? And the rain caused by thunderstorms or cumulonimbus clouds is of short duration. So rain duration is not very long. Rainfall will happen over a short period of time. Okay. So this is about equatorial type of climate. In savanna region, monsoon region as well as Mediterranean region, there is high level of seasonality. Seasonal variations in temperature and rain are very high in all the three regions. In Mediterranean region, winters are rainy, summers are dry. Summertime temperature is more than 25 degrees Celsius. Winter time temperature is around 8 to 12 degrees Celsius, correct? So there is high level of seasonal variability. In savanna and monsoon region, the summers are rainy, winters are dry. Okay, monsoon region that receives relatively higher rainfall than savanna, but seasonal variability is again high in these two areas too. So this region has all the days of the year same. The annual range of temperature in equatorial region is just 2 degrees Celsius, which clearly indicates that all the days are same. There is no difference in temperature of days in January or July. So this is the kind of simple type of question. Anyone who has knowledge about different climatic regions of the world could tackle this question. The next question is, in the South Atlantic and Southeastern Pacific regions, in tropical latitudes, cyclones do not originate. What is the reason? See, cyclones generally develop in the northern tropics, correct? And there are only some southern tropical areas like southwestern Pacific, where tropical cyclones develop. Generally tropical cyclones, in fact tropical cyclones do not develop in southern Atlantic and southeastern Pacific. Let me show these areas on the map with this is Pacific Ocean, this is your tropical ocean. This is Atlantic Ocean, this is Pacific Ocean. So question talks about these two areas, that is Southern Atlantic, and second is Southeastern Pacific. Cyclones develop in this area. In Southwestern Pacific Ocean, cyclone formation takes place. Correct? Neither cyclones develop in this area nor in this area. Now let's check the options. What are the options? The first option is sea surface temperatures are low. Why cyclones do not develop in these two areas? First option suggests that sea surface temperature is low, and that might be the reason. Definitely, the formation of cyclone, tropical cyclone, is linked with sea surface temperature. The sea surface temperature of a place must be at least 27 degrees Celsius to fuel the formation of tropical cyclone. So, tropical cyclones do not develop in areas where sea surface temperature is lower than 27 degrees Celsius. Correct? So, it seems that first statement is correct. Let's check the other statements. B is intertropical convergence zone seldom occurs there. Intertropical convergence zone is the zone where trade winds converge. And due to convergence of trade winds, in this area, there is high level of humidity. Imagine this is Earth's surface. Imagine this is Earth's surface. This is trade wind of northern hemisphere. This is trade wind of southern hemisphere. And this is called as ITCZ, Intertropical Convergence Zone. The trade winds bring a lot of humidity and heat from surrounding areas and accumulate this heat in ITCZ. So, ITCZ is the area of formation of ascending currents, thunderstorms and tropical cyclones. Okay. So, the point is tropical cyclones do not develop in all the areas where temperature of seawater is high. Even in warm areas, tropical cyclone may not develop if what is not there? ITCZ is not there. Correct? So, second option is better than the first option. Means ITCZ is must. If ITCZ is not there, cyclone will not develop. If temperature is warm, still cyclone may not develop if ITCZ is not there. Okay. So, presence of ITCZ is must for formation of tropical cyclone. And in southern Atlantic or southeastern Pacific, ITCZ very rarely present. ITCZ in these areas generally remains north side. And due to lack of ITCZ, the tropical cyclones do not develop. Okay. The third statement is Coriolis force is too weak. No, Coriolis force prevents the formation of cyclone near equator only, because near equator tropical cyclone is weak. But in other areas, if you talk about tropical zone, the Coriolis force is not the problem. Coriolis force is sufficient to fuel the cyclone formation. So, this factor explains lack of formation of cyclones at equator, 5 degree north to 5 degree south. It does not explain absence of tropical cyclones in southern Atlantic or southeastern Pacific. Absence of land in those areas, no, this is also incorrect, because in both areas we have land masses. So, that is not the explanation. So, A and B both are correct, but as I told you, B is better answer. B is more accurate than the A, because the presence of intertropical convergence zone is absolute requirement, whereas temperature is a relative requirement. Clear or not? So, in this question, B will be the correct answer. Although some of the scholars, they support the first factor, I will always support the second factor, because you know what, in tropical areas maybe the temperature is high, but the winds, they sweep the moisture and latent heat and accumulate it in the ITCZ. The latent heat which is present in the water vapor in the air, that is the main source of energy for tropical cyclone. So, tropical cyclone will develop in those areas where a lot of vapor and latent heat is available. Okay. So, and that is present in which area? ITCZ area. So, in this question, B statement is correct. Thank you.